We will miss the end of June by that much time right there. Now comes the important question. Typically to a product owner. Hey, product owner, what's more important on this particular project? The date or the scope?
Date.
In my world, the answer to that is often yes. They're both, right? I need all those features and I need it by the date. Well, if I'm unwilling to drop scope, I'm unwilling to give you any more time to get the job done, and I think everybody can pretty much appreciate the idea of throwing more people at a late project, at least according to Fred Brooks, just makes it later. So throwing bodies at this late is not likely going to help and almost certainly will hurt. There's only one thing you can do. You have to work really, really fast. Look at the slope of the velocity curve. The steeper the slope, the faster the velocity. A vertical line on a velocity graph, infinite velocity. Right? So you want a steep line, but there's only one way you can work that fast. You have to cut corners. Well, we didn't really design it the way we should have designed it, and we didn't really build it the way it ought to be built, and testing, did the best job we could with the time we had. Automating tests. Who's got time to do that when you're running with your hair on fire? No, we wouldn't do any of that. All the stuff we should have done, but we didn't do, that's the technical debt. That's the stuff shading in the blue area. Okay. Well, everybody understands that the real problem, of course, doesn't happen during release 1 per se. Release 2 gets interesting. I like release 2 on that date. If we project out our velocity, we're going to get release 2. We're going to go off the slide here. No, you have to meet my crazy date with my crazy set of features again. Go really, really fast. Say hi to the next set of technical debt. Oh, and by the way, notice that the velocity in release 2 actually is slower. It's not as steep in release 2 for the obvious reason. In release 2, you have to build on top of all the compromises you made in release 1. Right? So all those little shortcuts you took. So now it's like, every time I go into that code, I have to dance around all the shortcuts we put in release 1. By the way, that's your interest payment on the debt. You didn't think the debt came without interest. It's the whole point of using the metaphor of technical debt, because it implies to everybody involved there's interest that we pay. All that extra time that we have to spend dancing around the shortcuts, that's our interest payment. If we paid back the principal, refactored the code, cleaned it up, you wouldn't pay the interest anymore. So the problem is this keeps going. And you know what happens over time, right? Over, not days, right? Not weeks. We're talking months, years on big systems. You start to accrue so much technical debt that for all practical purposes, velocity goes horizontal. If vertical velocity was infinite velocity, horizontal velocity means you can't get anything done. Now, maybe you've worked on a system like that. I have. If you're laughing, that means you have, right? You know the one I'm talking about, right? That system where touch anything over here. 18 things over there will break. You have no clue which 18 things they are, and we don't even have enough of a test framework in place to even know they broke. Don't worry, I'm sure our customers will be happy to tell us which 18 things we broke.
Yeah.
Here's the sad news. If you find yourself in that position, you have no good options left. You have options. You have no good options left. Think what your options are in the presence of massive technical debt, when you cross the tipping point. Option 1. Yeah, or how about do nothing? We'll just ignore the problem, do nothing. It gets worse. Option 2. Declare technical bankruptcy. Retire the system, and therefore retire all the technical debt in the system, and then take on the full cost and full risk of starting over.
With fixed scope and fixed time.
With scope creep and all the stuff that goes with it, right?
Yes.
So you have a number of options here, right? You can trash the system, do nothing about it, right? Anything else come to mind?
Without paying the principal.
Let's see if we can work together, come up with some ideas. All right. I mentioned that in '92, Ward Cunningham use the term technical debt. He was working at a financial services company, and he wanted a way to communicate to the business people at the company the idea that when we take these shortcuts and do things like that, it accrues debt. It causes a problem, and he needed a way of communicating with financial services guys who use the debt metaphor, right? And so that's actually the way he stated it in 92. Now, in 92, the term refactoring hadn't yet come into common usage, otherwise it would have been in that paragraph. Word's a friend of mine, I used to talk to him about this. I go, why do you say refactoring? He's like, because the word didn't exist. Not yet. Today, I'll suggest to you that technical debt has come to mean all the bad things about our software. I think his original usage has been co-opted and is now kind of a bit abused. So all the things that can be bad about software, such as bad design, which by the way was what he was originally intending to discuss. Our current design is unfit for the purpose we have today. It might have been fit for the purpose when we designed it, but things have changed, the business has evolved, and the current design, well, it's not adequate. We don't have a place to insert our new feature that we want in the design. But defects, a lot of teams you'll hear talk about, oh yeah, we got a lot of technical debt. What do you mean by that? We have like 5,000 items, in our defect tracking system. Okay? Or we just don't have enough test coverage. I think about this question for a moment. What percentage, on a product that you're working on right now, or one that you're familiar with, what percentage of your tests are automated?
0.
0? So 100% manual testing debt. By the way, hard to be agile when you don't automate your tests. However many times I happen to mention automated tests over the next hour or so, I actually meant to mention it about 100 times more. I just couldn't insert it into every sentence I was saying. So maybe now you have an idea of how I think about automated tests and how important it is to being agile long term. It could just be, there's manual testing, poor integration and release management. Could be dead. We're talking about, when Barry was up here saying we're putting out releases. Well, 48 hours to get a release out. I've been in companies where a release was a week-long cycle. Wow, when it's that painful, you don't want to do it very often, right? Actually, in this company, my primary suggestion is always, if it hurts that much, I hereby declare you must release every day. No, because you'll fix it, right? You'll find out why it's taking a week, because you won't want to suffer that pain once a week. So really, the thing that's bothering you the most, start doing it every day, and you'll get good at it. You'll find a solution for it. Lack of platform experience, that was our Y2K problem. We had platform debt, right? In 1999, right, a lot of the people who really understood COBOL had already decided to retire. There was platform debt there. So you can see it's multidimensional. So I'm suggesting that today that term has a very wide net. It's very broad in its usage. All right, now I'm going to define 3 types of technical debt. These are my definitions because when I was writing the chapter of the book, I really needed a way to express that there are some distinct ways of looking at debt. First will be what I'll call naive debt. I will define each of these. Right, the second is what I'll simply refer to as unavoidable technical debt, and the third is strategic. Let me clarify what I mean. When you think about naive technical debt, I'm suggesting that one way we can have it really is through business immaturity. I want all these features by the end of June. By the way, that's a totally ridiculous thing to request. Well, too bad, that's why you guys get paid, figure out how to do it. It's naive on my part to believe that just because I declared it, it can be done, right? I think date and scope play a game of chicken. These guys are coming right at each other. One of them had better make way. If they don't and they collide, that's how most organizations accrue huge technical debt. They're being unreasonable. So I know the old joke, date, scope, and budget, choose any 2. Wrong. You can't choose date and scope. Sorry. Locking those 2 down locks down 2 constraints and over-constrains your problem. You need flexibility along one of those dimensions. Typically in Agile, what's the dimension we want flexibility on? Absolutely. Scope. Scope is the degree of freedom most Agile organizations put into play. Not always, right? Sometimes the date is the critical one, scope is the critical one, and date is allowed to be flexible. But in most Agile organizations, you lock down date, you lock down budget, you let scope be flexible. Here's a rule. The other way naive technical debt comes in is just naive about technical practices. right? A lot of you will probably recognize those as like XP type practices, extreme programming type practices. Well, if you don't apply, there's a reason why these things exist. So if you're not doing these, chances are at a developer tester type level, we're just making naive mistakes. Things that we could avoid, but we're not. Hence the concept of naive technical debt. It's going in because we've made naive choices, naive decisions. Totally preventable, right, with the right kind of training and technical practices, or maybe having involved discussions with senior management to convince them that what they're trying to do is really not a sensible thing. Unavoidable technical debt. We always have to make assumptions. I call this the learning. You make an assumption. Then you have to build something so that you can validate whether the assumption you just made was correct or incorrect. And then we can inspect and adapt, right? The heart of agility is inspecting and adapting. Well, we can make an assumption, build something today, and it works, right? These components, they line up very nicely. But over time, things start to evolve. And those components that once fit together very nicely, not so much today. What if we license a third-party product, we program to the API provided by that third-party product, and everything works well today? And then the vendor from whom we have licensed the product makes changes to their API. Our stuff that once worked beautifully no longer works so beautifully. I call that unavoidable. You could say, well, what? We should have programmed defensively against changes that the vendor might make in their API. Yeah, I'm not that smart to predict any change they might ever make, right? So sometimes it's just unavoidable, but when we determine it's happened, then we have to fix it. So we have to deal with the consequences, even if we can't prevent the cause. More on that in a little bit. And then you run into strategic technical debt. The idea here is simple, and I bet many of the organizations, if not most of you, do this. You'll have someone go, I understand we have to rush and cut some corners to get this thing into the market, but it's the right business thing to do. Because the economic return by making those shortcuts outweighs the cost of the technical debt. So please cut the corners. Now, most of the time, that's just dead wrong. There are some instances where you can make the economic argument for why you would do that.
In the case of the derivative, wasn't that the case?
Absolutely. There's a great example. In the derivative example, it's like, I need to get